Alright, and here we are in RL low pass filters. I had gotten way into the videos and then suddenly realized that I had completely forgot all about filters. So here we are. This is a low pass filter, and we're going to start with talking about how we determine the orientation of the components, and then we're going to talk about identifying the filters. So first off, if you look at this filter right here, you can see that L1 is in series, right? Here's the input and here's the output. There's one path through L1. It is in series with the output. Now R1, on the other hand, is in parallel with the output, because if our input is here, there is a path here, and there is a path here. So two paths, that's a parallel circuit. So R1 is in parallel and L1 is in series. All right. But if you were looking at a single path right here, right, then you could see that L1 and R1 are in series with each other. So that's kind of the first part that you need to understand about filter circuits. It's going to make, when you get to arrow logic, a lot easier. Okay, so now that we've gotten past orientation, let's talk about how we identify. So I'm going to give you kind of a picture mnemonic that we often use to identify our filters. So if you think about an inductor, it kind of looks like rolling hills. And there's a nice little picture so you can see those rolling hills. Now, hills are lower than mountains, and a resistor has those nice sharp jagged peaks that kind of look like a mountain range. So when your inductor is on top, that's where your hills are. And so your hills are lower than mountains, so you know that this is a low pass filter. Now if your resistor was on top, in other words in series with the output, then it would be a high pass filter because mountains are higher than hills. So there's a little picture concept mnemonic, hopefully, that will help you to identify your low pass from your high pass filters. All right. The other concept we look at is frequency cutoff, and that is abbreviated FCO. Now frequency cutoff is the frequency that will make your inductor the same ohmic value as your resistor. And there's a formula for that, and here it is. So resistance over 2 pi times inductance. And in this case, if you put in the numbers that are here on the screen, you will get 17.37 kHz. And we'll put that over there on our formula, or on our circuit. So at frequency cutoff, that is when our two ohmic values are the same. XL and R1 are the same ohmic value. And when they are at that point, we have a voltage that is something called the half power point. Now that half power point is where usable voltage begins and ends. So at 17.37 kHz and below, because this is a low pass filter, because it is a low pass filter, it says what it does. It passes low. So at 17.37 kHz and below, we are going to have a usable voltage. It will start out at 70.7% of incoming voltage and continue to get higher the lower that frequency goes until it gets to its incoming voltage. Now, if frequency were to go above the frequency cutoff, we would get further and further away from usable voltage. So everything above 17.37 kHz is going to give you an output voltage that is below usable voltage. And we call those filters ineffective filters because they do not make an efficient use of incoming voltage. Now, the ones that are at 70.7% of incoming voltage or above, we call those effective filters. All right, so the half power point, I know it talks about power, but it is the half power point, but it is actually a voltage measurement. And it's abbreviated HPP, and all you do is take 70.7% of incoming voltage. In this case, we would take 15 times 0.707, which is 70.7%. You can put it into your calculator either way. You can use times 0.707, or you can use times 70.7%. In any case, you end up with 10.61 volts. So that's the voltage cutoff. 10.61 and greater is an effective filter. Below 10.61, ineffective filter because of that voltage output. Because 70.7% is the amount of your AC voltage that you need for usable voltage. Alright, and that is the basics of a low-pass filter. We're going to move on to a high-pass filter. Should be a little faster because we're just kind of refresh and go over these one more time.